Okay, so example one, we have cost of a pizza if toppings are 50 cents. So the number of toppings is your independent variable. So number of toppings, independent variable, and then the cost is your dependent variable. So number of toppings and cost. And if you had to further define them, number of toppings is a whole number. It's always going to be a whole number. You can have one topping or two toppings. I've never heard of anybody ordering half a topping. So number of toppings is a whole number. So that makes it discrete. Now the cost is 50 cents per topping. So if you had one topping, it'd be 50 cents. That's a decimal. So that is a continuous variable. So there's the major difference. We've got number of toppings and cost, and number of toppings is independent. It is a discrete variable because it's whole numbers. Cost is dependent, and it is it's a continuous variable because it has decimals. Now, this particular scenario, if you had 0 toppings, you would start at 0, 0. And then if you had one topping, you'd go up 50 cents. And if you had 2 toppings, you'd go up another 50 cents. And then another topping, you go up 50 cents. And so there's a straight line. Well, that's not a very good straight line. But there's a straight line with a jump of 50 cents for every topping that you increase. The other thing, another definition that you need to know is what's called direct variation. Now, direct variation is when a linear relationship like this starts at 0, 0. So it's a direct variation whenever it starts at 0, 0. So this would be a direct variation. We're going to look at an indirect variation next. All right, welcome back, grade 9s. Hopefully you had a good weekend. We're going to begin the new unit. It is Linear Relations, Unit 4, and we're going to start with the lesson 1. It has a number of definitions. I'm not going to get into every single one, but I'll just get the gist of kind of the terms that you need to know. So first of all, if you've had any kind of experiments done in science class or maybe a science fair in elementary school, then you know something about variables. So you have 2 different types, the independent variable, the dependent variable. If you were going to, say, for example, study the growth of a bean plant, and you wanted to look at some effect of either an amount of water, amount of sunlight, you could be creative and come up with something different, like different types of fertilizer, different nutrients that you put in to see how that affected the plant's growth. So for the independent and dependent variables, the independent variable is the one you're changing predictably. So if you change the amount of sunlight for each plant, that is the independent variable. That's the one you're actually changing. And the dependent variable is the one you're always measuring. So if you measure the height of the plant, that's the dependent variable, and the independent is the one you're changing predictably. The dependent is changing unpredictably, and you're measuring it. And that's typically how you can tell the difference between the two. Now, when you're graphing the two, it is independent variable, goes along the x-axis, so it's the one that's horizontal. And then the dependent variable is the vertical one on the y-axis. So that's how you would graph it. There's a few other terms that they cover. For example, if the variable is able to have decimals, then that would be considered a continuous variable. And then if it's only whole numbers, that's a discrete variable. So we'll get into the first example, and hopefully that'll kind of make it more clear. So I'm just going to do that now. Okay, so the next example is Tatiana's Bowling Company, who charges $3 to rent shoes for the evening and $2 for every game played. So let's just write that down here. So we've got $3 for the shoes. You have $2 per game. So $3 for the shoes and $2 per game. Now, the next part of this lesson is going to be slope. And one of the ways of knowing when you have a situation like this, what slope is always it's a ratio. It's a per something. So $3 for the shoes for the night or $2 per game. The $2 per game gives you a hint that that is actually going to be what's called the slope. And we'll get into what the slope is in a moment. But for now, we need to label the variables in the question. So the constant, which we haven't talked about yet, but it's the value that stays the same regardless of what happens. The constant ends up being the shoes. So $3 for the shoes, that's called the constant because no matter what happens, you got to pay the $3 for the shoes. So constant, $3 for the shoes. Now you've got an independent and a dependent variable. So I'm just going to put an I for independent. Now, which one is changing predictably? If you wanted to change the amount you paid, you could change this predictably and it would result in affecting or changing the other variable. The independent variable in this one is the number of games. You can change that predictably. You have control of that. And what that's going to end up changing is the dependent variable, which is cost. So the cost for the night is going to depend on the number of games you play. But regardless of how often you play, you've got a constant in that you pay $3 for the shoes to bowl. Okay. Now, the next question says, fill in a table of the cost of renting shoes and playing games for 0 to 4 games. So let's take a table of values. Now, we have X and Y. Those are our axes, X and Y. And X, we talked about, let's take a look at a graph. So the X is the horizontal and the Y is the vertical. So your independent variable goes on the X, your dependent variable goes on the Y. Before we can graph this, we need to know the situation. So for our X, we're going to go and predictably change it. So the least number of games you could play would be 0 games, or 1, or 2, or 3, or maybe even 4 games if you decide to spend your entire day at the bowling alley. So 0 to 4. Now, we talked about the constant. You have to buy the shoes. The shoes cost $3 no matter how many games you play. So even if you played 0 games, you would come up with a cost of $3. Now, if you played 1 game, each game costs $2. So for 1 game, you've got your cost of $3 for the shoes plus $2 makes 5. For 2 games, 2 times 2 is 4, plus 3 is 7. And at this point, you can kind of see 3 goes up to 5, goes up to 7. It's going to go to 9, and then 11. Each of them jumps 2. And because they jump by 2 each time, that indicates that it's a line. It's a linear relation because they go up by the same amount each time. So 2, 2, 2, 2, 2. And that will continue. Okay, the last part of this bowling question asks you to graph it. So in our x-axis is the independent, and we have number of games. And the y is the dependent, and that is the cost. So you're going to start with 0 games, then 1 game, 2 games, 3 games, etc. So 0, 1, 2, 3 continues indefinitely. So you can put an arrow there because that indicates that it keeps going forever. Same thing with cost. It's going to go on forever. And maybe we'll go up by 2s. So 0, there's $2, there's $4, there's $6, there's $8. All right? And so 0, 2, 4, 6, and 8. Got my graph labeled. That's the best way to start this thing. So now looking at our table of values, we're just subbing in the points. We had a table of values that said at 0 games, we still had to pay $3. So I'm going to put a dot where 3 is. It's kind of in between 2 and 4, right in the middle. So I'm going to put the dot there, $3. If I play 1 game, I'm up to $5. So I'll go over to 1, up 5. If I played 2 games, I would be at $7. So for 2, I'm going to go up to 7. And then for 3, I'm at $9. Over 3, up 9. I should have a straight line linear relationship. And so that's it. That's how you would graph that line.